All right, so we're going to work on a solution for problem 617. What I've done at the top of the page is I have simply repeated the table that shows up in the problem, and what we're going to do is work on the ABC cost allocation and then figure out the margins for the two products, and then work on understanding the difference or explaining why the margins change so much from our first allocation of costs. So, with every cost allocation, the most important thing to figure out is the rate, the allocation rate. So just like with CVP analysis in Chapter 3, the important thing is to do the contribution format income statement and solve all your problems that way. When it comes to cost allocation, what you want to focus on is calculating and using the rate. At least that's the way I understand allocation. And I write your quizzes and exams, so you should at least pay attention to that. So the rate is always going to be the overhead dollars divided by the allocation base or the cost driver. So we have our four pools: machining, setups, product sustaining costs, and other. Now you'll note for the other, we don't have a cost driver because these are organization sustaining costs, and so we don't have to come up with a rate. So we do have three pools for which we have to come up with a rate: the machining pool, the setup pool, and the product sustaining pool. So let's go ahead and do that. For the machining, our overhead cost is the $198,250. And our cost driver is going to be the total of the number of machine hours. So we're going to divide the $198,250 by 152,500 machine hours. And we put that into our calculator, and our calculator lies to us and tells us 1.3. We need to recognize that this is $1.30 per machine hour because we have dollars on the top and machine hours on the bottom. And so our allocation rate is $1.30 per machine hour. For setups, our overhead cost is the $150,000. Our cost driver is setup hours. And how many setup hours do we have? Well, for the two products, the total is 375 setup hours. And so again, we put that in our calculator, and our calculator tells us 400. But of course, we have to make that $400 per setup hour. And then finally, for the product sustaining costs, so we spend $100,000 managing the fact that we have two different products in our product portfolio. We're going to allocate that on the basis of the number of products in our product portfolio, and we have two products in our product portfolio. Now, if you put this in your calculator, go home. You don't belong in college if you have to use your calculator to divide 100,000 by 2. So your calculator or your brain should tell you it's 50,000, and your brain should also tell you it's $50,000 per product. And again, we don't have to allocate the other costs because they're organization sustaining. There's no cause and effect relationship between them and any of the products. So we have our three rates. For the machining cost pool, we have a rate of $130 per machine hour. For our setup cost pool, we have our rate of $400 per setup hour. And for our product sustaining cost pool, we have our rate of $50,000 per product. Now, let's allocate the overhead costs, these three kinds of overhead costs that are going to be allocated. Let's allocate them to the EX and then to the TX. To allocate the machining costs, we're going to take our $1.30 per machine hour multiplied by how many machine hours are used by the EX. 90,000 machine hours, so $1.30 times 90,000. And that gets us $117,000 allocated to the EX. And to the TX, we're going to take $1.30 per machine hour, multiply it by the 62,500 machine hours, and that gives us, 62,500 machine hours, and that gives us 81,250 getting allocated to the TX. So the machining cost, 117 is allocated to the EX, 81,250 is allocated to the TX. Together, that total is 198,250. For setups, we have our $400 per setup hour times 75 setup hours for the EX. Setup hours cancel, 400 times 75, and that gives us $30,000 of setup cost allocated to the TX, to the EX. And then for the TX, we have $400 per setup hour times 300 setup hours, and that gives us $120,000 of setup cost allocated to the TX. And again, 30,000 plus 20,000 equals the 150,000 total cost to be allocated for setups. And then finally, for the product sustaining costs, we have $50,000 per product times one product. That's the EX is one product, and that's going to be $50,000. Essentially, we're just splitting this cost equally among the products, and we're going to do the same thing over here. So $50,000 is allocated here, and of course 50 plus 50 is going to equal 100. So we've done the same thing we've always done with cost allocation. We've come up with a rate, used that rate, multiplied it by the use of the cost driver for each of our products. Fill this in here. And that gives us the amount of cost allocated. So these are the three types of manufacturing overhead costs allocated. We also have the non-manufacturing cost, the advertising cost, that we were told in the problem is traced directly to the two products. And so we have a total of $50,000 of advertising cost allocated to, traced directly to the EX, and $100,000 of cost traced directly to the TX. And so if we look at all of these costs together, the three types of overhead cost plus the advertising cost, we have what we can call the total ABC cost. In other words, the total cost assigned or allocated to these products based on the ABC understanding of how to allocate indirect costs. And so we can total these up. For the EX, 117 plus 30 plus 50 plus 50, the total cost attached to the EX product for the activity-based costing system would be $247,000. And for the TX, 81 plus 120 plus 50 plus 100 gives us $351,250. That's the total ABC cost allocated. Now remember, the whole point of why we're doing activity-based costing is to come up with product profitability, which we're going to measure with this concept called product margin. And the product margin is going to be the sales revenue minus the product cost, which is going to be direct material, direct labor, and here we'll take the whole ABC cost and add it into one, and we subtract all those costs and we'll get the product margin. So for the EX, our revenue that we figured out last time, their selling price and the number of units doesn't change. So our revenue is going to be $1.2 million. Our direct material cost is going to be the same. That's not changing, $366,325. Our labor cost is $62,550. $62,550. That's given. $66,325. Our labor cost is $120. That's not changing. And the ABC cost is the $247 that we calculated at the bottom of the last page. And so if we subtract all of those costs, $1.2 million, minus our direct material, direct labor, and ABC cost, our product margin is $466,675. And I'll label this the ABC margin because it's the margin we calculate using the ABC approach. For the TX, our total sales revenue, again, isn't changing. That's $500,000, which we calculated before. Our direct material is $162,550. That's given. Our labor is still the $42,500. And our ABC cost is the $351,250 that we just calculated at the bottom of the last page. And so our margin is going to be a negative $56,300. In other words, we are, according to the ABC way of understanding cost, we are losing money on the TX. Let's compare these to the margin we calculated based on the job order costing. Which again had allocated our overhead costs simply on the basis of direct labor cost. For the EX, it was $338,075. And for the TX, it was $161,925. So, again, if we think about what we're trying to do here, we're trying to figure out the margin or the profitability of our products. Under the ABC approach, we're thinking very carefully about how the overhead costs are allocated, and we're trying to allocate those overhead costs on the basis of how the products actually use our overhead resources. So if we think about, if we go back to the prior page and we look at the use of cost drivers here, I'll rewrite them down here as I talk. If we think about direct labor cost, which was the old cost driver, the EX used $120,000 of direct labor, and the TX used $42,000. Used $120,000 of direct labor, and the TX used $42,500 of direct labor. So that's about 74% and about 26%. So if that's the way we allocate overhead costs, since the EX used 74% of the direct labor, it got 74% of the overhead cost. And since the TX only used 26% of direct labor, it only got 26% of labor cost. But if we take the cost drivers we used under the ABC approach, the machine hours, the EX uses 90,000 machine hours, and the TX uses 62,500 machine hours. That's about 59% and 41%. So the overhead costs that we allocate using machine hours, the EX still gets a higher proportion of them than the TX does, but it's not quite as skewed. It's a little bit more reasonably balanced. Instead of 74 to 26, it's only 59 to 41. So it's a lot closer to being even. And then you look at the other resources, setup hours. The EX uses 75 and the TX uses 300 setup hours, which is 20% and 80%. The TX actually uses more setup hours than the EX does. So more of the setup cost is being allocated to the TX. And then if we look at our product sustaining costs, they're each one product. They're each one product, and so we're going to split those costs equally 50-50. And what we see is when we think carefully about the resources that we use to make our products, the TX consumes a much higher proportion of all of those than it consumes of the labor hours. In other words, the TX is made less efficiently than we would have realized if we'd only used direct labor hours as the way to allocate overhead costs. So by looking at our costs in terms of the specific activities it takes to make our products, we can see that we spend a good chunk of our overhead resources, we use up our overhead resources to make the TX in a much bigger proportion than the labor costs would tell us. So why do the margins change? Why does the margin increase when we go from the job order approach to the ABC approach? Why does the margin increase for the TX, and why does the margin decrease for the TX? Why does it increase for the EX and decrease for the TX? It does so because the TX uses all these resources at a much higher proportion. So ABC allocates overhead based on the proportion of overhead resources used by the products. If a product uses a greater proportion of the resources, it's going to get a greater portion of the cost allocated. And a product that uses a lower proportion of the resources gets a lower portion of the cost allocated. Just like if you go back to the Sunday school example, and we had the two families, and one family had a lot of people, and the other family had few people, and the family with a lot of people got more cost given to them, or more money given to them. The same way, it's the proportion of resources used that's going to determine the overhead cost allocation. So why does the margin change? The margin changes because the proportion of resources, or the proportion of cost drivers, changes. The allocation follows the cost drivers. So that is requirement 3 for the good faith effort assignment. So I hope this was helpful. Let me know if you have any questions or thoughts. Thanks.